Okay, so we are going to start the paper over here, which is actually the paper of 2020, and this is the October-November paper, right? And paper 2 to the variant is the second variant, right? You can see this, the overall paper is of 60 marks, right? You need to complete these 60 mark questions in just 1 hour and 15 minutes, right? So let's start with the question number 1. Just look at over here what the question number 1 is saying to you. They are saying that atoms contain the subatomic particles, electrons, protons, and neutrons. Protons and electrons were discovered by observation of their behavior in the electric field, right? The diagram shows the behavior of separate beams of electrons and protons in an electric field, right? What they are saying in part 1, they are saying complete the diagram with the relative charge of each of the electrically charged particle, right? The charge of the particle. So you can see this. We know that they are asking for the charge of the plate, right? We know that protons are positive, so definitely they are moving towards the negative plate, right? So it must be negative, and we know that electrons are negative, so it must move towards the positive plate. So this is the charge of the plates, right? Then they are saying on the diagram, draw a line to show how a separate beam of neutrons from the same source behave in the same electric field. We know that, but show that neutrons are neutral, so definitely they never deflect towards negative or positive plate, so they will move straight from the beam, right? So it will be like this, or you can say that it will be straight like this, right? You can use the scale for drawing this, right? Then in part B, they are saying that electrons in an atom up to krypton 36 are distributed in s, p, and d orbitals. State the number of occupied orbitals in an isolated atom of krypton 36, right? So over here, we need to talk about the number of electrons in s orbital overall, right? So you can write electronic configuration for this: 1s2, 2s2, 2p6, 3s2, 3p6, then 4s2, and then 3d10, and 4p6. This is the overall electronic configuration of krypton 36. So you can see this, that how many s orbitals are over there: 1, 2, 3, and 4. So we have 4 s orbitals. We know that s only have 1 orbital now, so we have total 4 orbitals of s over here. If you talk about p, so each p contains 3 orbitals. So it has 1, 2, 3, 1, 2, 3, and 1, 2, 3. So total we have 9 orbitals over here. If you talk about d, so over here, if you talk about d, so we just have 3d over here, and each d subshell having 5 orbitals. So it is 5. Is that right, Bacho? This is B part 1, and now we are moving towards B part 2. What they are saying, complete the diagram to show the numbers and relative energies of the electron in an isolated atom of silicon. They are asking to write what electronic configuration of silicon over here. We know that 1s2, 2s2, then 2p6 like this, then 3s2 and 3p2. It will be like this, right? And then they are saying that the diagram shows a type of orbital, and they are asking to state the total number of electrons that exist in all orbital of this type in an atom of fluorine. They're asking for fluorine. If you talk about fluorine, so it is 1s2, 2s2, and 2p5. So this is actually dumbbell shape, and dumbbell shape is for p orbital, right, or p subshell, right? So we have total 5 electrons over here in fluorine in the p subshell, right? Then part 4 is saying the first ionization energy of element in the first row of the d block, scandium to copper, are very similar for all these elements. It is a 4s electron that is lost during the first ionization energy, suggest why the first ionization energies of these elements are very similar, very similar. So what is the right answer for this? If you talk about the answer for this, bacho, so definitely if you talk about from scandium to copper, so over here the proton number is increasing. So you can say that nuclear charge increases. You can say that nuclear charge increases from scandium to copper, right? I'm not writing the complete phrase or the complete statement or the frame of the answer. You need to solve this in the way like you need to write from scandium to copper, the nuclear charge is increases, right? And we know that why the nuclear charge is increasing, because the number of protons in the nucleus are increasing, right? But if you talk about the last shell, which is the last shell is 4s, right? The electrons are not adding in the last shell. The electrons are adding over here in the 3D subshell, right? So you can say that extra electrons are actually, you can say that, are filling over here in 3D, yeah, D subshell, yeah, in 3D orbitals, right? So you can say that the electrons are increasing in 3D subshell. The electrons are not adding in the last shell, right? It is increasing in the third shell, right? So you can say that due to which, you can say that what? Due to this, we have increase in shielding effect, because the electrons are added in the second last shell, and all the electrons which are inner, they will repel the outer shell electrons, and this is actually shielding effect. So when the electrons are adding in the inner shell, so definitely shielding effect is going to be increased. So nuclear charge is definitely increasing, and shielding effect is also increasing. So shielding effect also increases. Shielding effect increases, right? Nuclear charge increases, right? So there is actually, you can say that, similar force of attraction between valence electron and nuclear charge. So you can say that almost similar electrostatic force of attraction between nucleus and valence electrons. That is why it is almost similar, right? Then in the C part, they are saying that hydron is a general term used to represent the ions of hydrogen. Over here, H positive, and they all are H positive, but there is a change in neutrons, so they are actually isotopes. They are ions of hydrogen isotopes, right? State in terms of subatomic particles in the nucleus. What is the same about each of these ions, and what is different? What is same in all them? What is the same thing over here? If you talk about, so you can say that they all have same proton number. They all have same proton number. So you can say that same proton number, and they are asking for subatomic particles. So proton number is actually connected with protons. So you can say that same protons, right? And if you talk about different, so you can see this in all of these, we have different mass number, and definitely proton is same for all of them. Definitely the thing which is changing over here is neutrons. So you can say that neutrons are changing, right? So you need to keep remember this. यहाँ पर आप proton number और mass number नहीं लिख सकते हो. आपको याद रखना है वो सबएटॉमिक पार्टिकल्स की बात कर रहा है, तो यू नीड टू डिफाइन ओवर हियर प्रोटॉन एंड न्यूट्रॉन. बहुत आसान सी बात है, बट बच्चे यही ये मिस्टेक करेंगे. वो प्रोटॉन और न्यूट्रॉन की जगह सेम प्रोटॉन नंबर और डिफरेंट या मास नंबर लिख सकते हैं, बट वी नीड टू राइट सबएटॉमिक पार्टिकल्स ओवर हियर, राइट? So let's move towards the question number 2. The question number 2 is saying the period 3 elements from sodium to sulfur all react with oxygen to form oxides. State the trend in acid-base behavior of the oxides of the period 3 element from sodium to sulfur. If you talk about sodium to sulfur, so it starts from, for example, if you talk about sodium to sulfur, so sodium oxide, magnesium oxide, aluminum oxide, then we have silicon dioxide, and we have phosphorus oxide, then we have sulfur dioxide and sulfur trioxide, and in the last we have chlorine oxide. और ये होता नहीं है ऐसे normally, So you can say that it is basic, then it is amphoteric, and then it is acidic. So they all are acidic, right? So first two are basic or amphoteric aluminum oxide, then all of three are acidic, right? So you can say that it is actually from more basic to acidic. Yeah, most acidic, right? You can write in this way, right? Let's move towards part B. If you talk about part B, the state and explain the trend from sodium to sulfur in the maximum oxidation number of the period 3 element in their states, right? So if you talk about electrons in the outermost shell's oxidation state increases from sodium is always +1, and it is increases to +1 to +6. Sulfur is actually +6. You can say that it is increasing, right? You can say that increases from sodium to sulfur, right? उसके बाद they are asking sodium oxide and phosphorus oxide both react with water. Name the product of each reaction. You need to name the product for each of the reaction over here. When you add sodium oxide into the water, definitely sodium oxide reacts with water and form what? Sodium hydroxide, right? You need to remember this reaction as well. If you remember, I told you this in period 3. So sodium when dissolved in water, when sodium oxide dissolves in water, it will form what? Sodium hydroxide. You need to keep remember this. Then we have phosphorus 5 oxide, right? So phosphorus 5 oxide means we have a oxidation state of 5 over here for phosphorus, right? So phosphorus is +5 and oxygen is 2 minus. So the formula between these two is P2O5. When we know that P2O5 dissolve in water, it will form what? It will form phosphoric acid, H3PO4, and this is actually what? Phosphoric acid, phosphoric 5 acid, right? The oxidation state of phosphorus should be 5 over here, right? If you talk about part D, so they're asking for what? Explain why phosphorus oxide has a low melting point of approximately 300, but magnesium oxide has a high melting point of approximately 2850, right? You need to explain this, and we know that magnesium oxide is giant ionic compound and phosphorus oxide is actually covalent compound. So if you talk about magnesium oxide, we have a strong electrostatic force of attraction over there, and in phosphorus oxide we have weak intermolecular forces. So that is why there is a difference of melting point over here. So you can simply say that first of all you need to talk about the force of attractions over here. Then you can differentiate over here or compare over here with the structure as well. So simply we can frame this answer in the way that magnesium oxide is giant ionic lattice with strong electrostatic force of attraction, strong electrostatic force of attraction. And you need to keep remember this force of attraction is actually between the ions. Strong force of attractions between the ions. You need to keep remember this between the ions, right? The ionic compound with force of attraction ions के दरमियान होती है. While P2O5 is a simple molecular structure. It is a simple molecular structure with weak intermolecular forces between the molecules. With weak intermolecular forces between the molecules. The intermolecular forces is always between the molecules. It is not between the ions. So you cannot use intermolecular forces with ions, or you cannot use electrostatic force of attraction with molecules. So you need to keep remember the difference over here. So weak intermolecular forces between the molecules, right? Therefore, MgO required greater energy to overcome. you need to compare over here as well for 1 mark. So this is actually the frame question for this question, frame answer of this question, right? Let's move towards part E. Part E is saying aluminum oxide reacts separately with both acids and alkalis. Write an equation for the reaction of aluminum oxide with aqueous hydrochloric acid. And we did this as well in period 3, right? Aluminum oxide is amphoteric, so it can even react with acids and bases also. So it will form what? AlCl3 salt and water, right? I just write the complete balance equation over here. You don't need to write the balance equation over here. It is only for 1 mark, so you can only write the correct formula of the products, right? Then they're asking for equation for the reaction of aluminum oxide with sodium hydroxide as well. So that's fine. You can even write equation with sodium hydroxide as well. And when we react with sodium hydroxide, for this we require 2 sodium hydroxides, right? And also over here we require water, right? So you need to keep remember that the formula of the product is NaAl, and this is hydroxide, 4 hydroxide, but we know that we require water molecules over there as well. So you can add 3 water molecules over here as well, right? You need to keep remember this equation, and if you are not remembering this, so you can go through the recording of period 3, right? We have 2 recordings over there on the YouTube, so you can see that, right? Describe the lattice structure of silicon dioxide. Yes, silicon 4 oxide. You know that it is giant covalent structure, right? And your answer should include the reference to the arrangement of the silicon and oxygen as well. And if you talk about the arrangement of silicon and oxygen, so it will be like this. And we know that the structures with 4 bonds are tetrahedral, right? So you can say that silicon dioxide is a giant covalent structure, right? And if you talk about the name of the structure, so it is tetrahedral. It is tetrahedral, right? Then in part G, they are saying sodium oxide and silicon dioxide reacts to form sodium silicate. Sodium oxide is obtained from the thermal decomposition of sodium carbonate. Write equation for the following reaction: sodium oxide and silicon dioxide. That's pretty simple. Sodium oxide is Na2O. It is basic in nature, and silicon dioxide is acidic in nature. We know that when they combine together, they will form what? Sodium silicate, right? And if you talk about the thermal decomposition of sodium carbonate, so it is also very easy. Sodium carbonate, when you heat this, it will break down into sodium oxide and carbon dioxide. Okay, so let's move towards question number 3. And the question number 3 is saying that PCl5, PCl3, and NCl3 are halides of group 15 elements. PCl5 can be formed from the reaction of phosphorus with chlorine, has a melting point of 161. Write an equation for the formation of PCl5 from the reaction of phosphorus and chlorine. That's pretty simple. We know that phosphorus is always P4, right? When it reacts with chlorine, Cl2, it will form what? PCl5. You can balance this by writing 4 over here. So phosphorus are balanced over here, 4, 5 is 20. And we can write 10 over here to balance that chlorine, right? Then they are saying state the type of structure and bonding shown in by liquid PCl5. PCl5 is a simple liquid of, and it is a covalent structure. So you can say that it is a simple molecular structure. Simple molecular structure, right? And they are saying a small amount of PCl5 is added to excess water. The PCl5 reacts vigorously to form a colorless solution. Give one other observation you would make when PCl5 reacts with excess water. So you can say that definitely there will be some HCl molecules. So you can say that this is steamy fumes, right? You can say that steamy fumes over there. Write the equation for the reaction of PCl5 with water. We know that whenever we add PCl5 into the water, we will have what? H3PO4 plus HCl. Right? For the balancing, you can add 5 over here, you can write 4 over here. It is balanced, right? Estimate the pH of the resulting solution. Both are very, very strong acids over here in the product. So you can say that 1. right? It is also the part of period 3, if you remember the recording of period 3. So that's very good, and it is very easy for that, easy for you, right? Then in part C, PCl3 is used to convert alcohol to chloroalkane, such as compound T. You can see over here. They are asking for identify a reagent that could be used in reaction 1. What is reaction 1? Just look at over here. In reaction 1, this is completely same. There is no change, right? This is completely changed. This is completely same. There is no change, right? Just a change over here is this one. We talk about the change. So this is actually carboxylic acid, and it is converting back to the alcohol, right? So this is the only change over here. When carboxylic acid changes to alcohol, what is the reagent that you can use? It is pretty simple. So what we can use over here, we need to use any reducing agent over here, and we know that a very common reducing agent in our syllabus is lithium aluminum hydride in dry ether. I just use the condition over here as well, just for your revision, right? Then let's move towards the part 2 of C. T exhibit optical isomers, right? Explain what is mean by the term optical isomers, and circle any atom in T that gives rise to optical isomers. We know that optical isomers is actually caused by the chiral center, and chiral center is what? When a carbon has 4 different bonds with different atoms, right? Carbon have 4 single bond with 4 different group of atoms or atoms. So what is the chiral center over here? If you focus, so I think so this one is a chiral center, because this is CH3 over here, and this is CH2Cl, and this is something different, and over here it should be H. So 4 bonds with 4 different group of atoms, so it should be the chiral center, right? If you want to write the definition of this over here, so you can say that optical isomers की definition आप क्या लिख सकते हो? You can write that isomer or a molecule which shows non-superimposable mirror images, right? So you can say that molecules which show, क्या बोलेंगे आप? Which show non-super, or you can use the word imposable mirror images, shows optical isomer. Perform optical isomerism. Right, now they are saying in part 3 that T is a minor product in the reaction of compound S with excess hydrochloric acid. Draw the structure of a major product of the reaction of S with HCl. S is going to react with HCl, and they're asking for the major product, and we know that H is always moved towards where the number of H's are great, where the number of H's are greater. So you can see this on this carbon, definitely H are 2, individual H's are 2 over here, so definitely Cl should be over here when that bond is going to be break, right? So you can draw the structure over here like this, that it will remain same. The double bond breaks, and when the double bond breaks, it must have chlorine over here, right? It will be the major product. It will be the major product, because we know that major product कैसे बनती है? जहाँ हाइड्रोजन इंडिविजुअल होते हैं, हाइड्रोजन हमेशा वहीं जाते हैं, ठीक है ना? या आप कह सकते हैं कि पॉजिटिव वाले हमेशा वहीं जाते हैं, ठीक है? क्योंकि अगर वो BrCl दे दे आपको, तो आपको ये कंफ्यूजन हो सकती है। तो Br पॉजिटिव होगा Cl की प्रेजेंस में, तो वहाँ चला जाएगा, ठीक है? And let's move towards part D. NCl3 is a yellow liquid that can be used to bleach flow. Predict the shape of NCl3 molecule and bond angle between NCl. Right, that's pretty simple. If you talk about NCl3, so we have 3 bonds of N with Cl, and also we have a lone pair on nitrogen. So the shape should be pyramidal. The shape should be pyramidal, right? Then if you talk about the angles, we know that what is the angle over there? It should be 107. Now they are saying that NCl3 reacts with water to form HOCl, a weak Cronstedt-Lowry acid. Explain fully what is meant by the term weak Cronstedt-Lowry acid. What is the definition of this? So you can say that first of all, you need to remember the Cronstedt-Lowry acid, and then you need to describe weak as well. So weak is the acid which is partially dissociated into the water. And what is Cronstedt-Lowry acid? Cronstedt-Lowry acids are the acids that donate their H positive ion, right? So you can say that substances that partially donate their protons, right? And what is protons? This is H positive ion, right? We always need to remember about the Martin scheme as well. If you focus on the question, it is of 2 marks. So definitely you need to define weak and Cronstedt-Lowry acid as well for 2 different marks, right? So that is why I use the word partially dissociation. And the second is donating H positive ion, right? Then let's move towards part 3 of this. They are saying that NCl3 decomposes according to the equation shown. A seed container of volume 2 centimeter cube contain an unreactive gas of pressure of 1 this, and 0.241 gram of NCl3 was injected into the seed container. 2 seed container was heated to make NCl3 decompose fully and then cooled to 20 degrees centigrade. Calculate the final pressure inside the seed container at 20 degrees centigrade after the NCl3 has fully decomposed. All right, so that is something very perfect question. So we need to try it. We need to solve this, and we require time for this as we just have 15 minutes left. So we just take a picture of this. We will solve this separately, right? We need to complete this paper in time. Just take a picture of this, Bacho. We will solve this later on, right? I don't have calculator right now. Done? Can we move on? Okay, let's finish the organic part first. If we have time in the end, so we will definitely do some calculation questions. Okay, so question number 4 over here we have, they are saying that some reaction of compound G are shown, right? And it states type of reaction that occur in reaction 1. Reaction 1. If you talk about organic chemistry solutions, you must need to use highlighters in the solution so you can identify the ho kya raha hai, chal kya raha hai. So you can just look at over here. It is what? Aldehyde. It is aldehyde. And over here you can see this aldehyde is converted into carboxylic acid. This aldehyde is converted into carboxylic acid. So it is very simple to identify the type of reaction over here because it is oxidation. Simple. But let's see this some other part of this as well. If you focus over here, this alcohol, and it is also going to convert into carboxylic acid. Now it's very simple for us to identify the type of reaction. It is oxidation. All right. Then if you talk about suggest the reagent and condition required for this reaction is also very easy. We need to remember this acidified. So acid, and you can use any acid over here, HCl or H2SO4. So you can say that acidified potassium dichromate, and it is asking for condition as well. So you can say that heat under reflux. We know that if you want to move towards carboxylic acid, so we must need to do heat under reflux. Draw the structure for organic product H from the reaction 2. So if we talk about reaction 2, so we know that over here we have alcohol, and this is aldehyde. This is aldehyde, and this is alcohol. We know that when you react Na with alcohol, it will produce some product. When you react Na with carboxylic acid, it will form some product over there, but there is no reaction of aldehyde with sodium. So definitely the structure will remain same from here. It will be unaffected. It will remain same, but change over here. We just need to replace H by Na. right? Now they are saying state what you would observe in reaction 3. What is reaction 3? We are adding Tollens reagent over there. Whenever you talk about Tollens reagent, definitely there should be silver mirror form. So you can say that silver mirror form, or you can say that silver PPT, silver mirror, right? Then give the type of reaction shown by reaction 4. Reaction 4 is you're using sulfuric acid, and also you are doing heat under reflux over there, right? So if you talk about reaction over here, so it is actually what? If you focus over here, so this is ester linkage. If you talk about this one, so this is ester linkage. Actually, these two combine together, right? So this is esterification. You can say that this is esterification, right? This is esterification process. Let's move on towards part B. If you talk about part B, bacho, so G and J are structure isomers of each other. Name the type of structure isomers shown by G and J. ये G and J जो हैं आपके पास, ये कौन से isomers हम show कर रहे हैं? If you focus over here, this is alcohol on the first, and this is alcohol on the second. So you can say that this is actually positional isomers. These are actually positional isomers, right? Then they are saying suggest one chemical test that can distinguish G from J. Get the result of the test with each compound. If you talk about G, so it is actually G having what? Aldehyde in this, right? So you can test this with even Tollens reagent, and even you can test this with the aldehyde, Phalings reagent as well. But the problem is this over here, we need to identify these two compounds. This is G and J. Definitely you will make a problem of testing over here. You always do what? You always do like Tollens reagent over here. You always use a Phalings solution over here, and many of you can even use sodium over here as well, and you can even use PCl5 over here as well. But this is not the right answer, right? अगर आप टॉलरेंस रिएजेंट यूज करेंगे तो दोनों में ही आंसर सही आएगा, दोनों ही टेस्ट परफेक्टली काम करेंगे क्योंकि दोनों में ही टॉलरेंस रिएजेंट मौजूद है. इफ यू यूज लाइक PCl5, तो इसमें दोनों ही अल्कोहल जो है मौजूद है, OH का हाइड्रोक्सिल वो आइडेंटिफाई करेंगे. इफ यू यूज फैलिंग्स टेस्ट तो दोनों में ही है टॉलरेंस, तो वो दोनों को आइडेंटिफाई करेगा, राइट? तो हमें इन दोनों को चेक करना है कि इन दोनों में से इन दोनों को सेपरेट करना है, इन दोनों को हमें अलग करना है. इन दोनों को अलग करने के लिए आप कौन सा टेस्ट यूज कर सकते हो बच्चों? यू कैन यूज आइडोफॉर्म रिएक्शन ओवर हियर, बिकॉज यू कैन सी दिस ओवर हियर. यहाँ OH के साथ CH3 लगा हुआ है. जब OH के साथ CH3 लगा होता है, so you can use आइडोफॉर्म रिएक्शन ओवर हियर, राइट? So what you need to do बच्चों, you just need to add aqueous alkaline, add aqueous alkaline iodine over here. If we talk about G, so definitely in G there is no change, because ये ऐसा कोई कंपाउंड है ही नहीं जो आइडोफॉर्म रिएक्शन कर सके. इसके यहाँ पर CH3 नहीं लगा हुआ. अगर CH3 लगा हुआ तो शायद कुछ कर लेता है, बट ऐसा नहीं है, ये नहीं कर सकता. यहाँ CH3 लगा हुआ है और OH भी है, और यहाँ डेफिनेटली H भी लगा हुआ होगा क्योंकि ये स्केलेटल फॉर्मूला जिसने आपको दिखाया नहीं. तो ये आइडोफॉर्म रिएक्शन का टेस्ट पॉजिटिव शो कर सकता है. So you will say that yellow precipitate forms. So this is one of the tests which is actually you can use to identify or you can distinguish these two compounds by this test, right? उसके अलावा आप जो चार टेस्ट मैंने आपको बताएं, वो चारों टेस्ट में दोनों ही परफेक्ट रिजल्ट देंगे. Alright. Then in the reaction scheme below, from G and J are converted into organic compounds compound K. You can see this. The scheme, reaction scheme, state the role of NaBH4 in the reaction with G and J. That's pretty simple. We know that NaBH4, sodium borohydride, is actually a reducing agent. So we can say that it is a reducing agent, right? Then they are saying identify the organic product K. यहाँ पर जो आपके पास product है K, उसका आपने बताना है क्या, identify करना है आपने उसको ना. So how can we identify this? Let's try to solve this. G is over there. G को आपने reduce किया. G जब reduce होगा तो ये alcohol में convert हो जाएगा, and both are alcohol. That's fine. Then when you use ammonium oxide and heat this, definitely the OH will be removed with H, and it will form a double bond over there. So let's see. We have what? We have a structure like this: CH2, 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 and this is OH. Over here we have CH2 and OH. When you remove this OH and H, you will have carbon-carbon double bond over here, right? And this is carbon, and when you remove OH and H from here, so you will have carbon-carbon double bond over here as well. All right. So this will be the structure when you remove the water molecules from there. So it will be carbon. These are 4 carbons, and the structure will be like this. Oh, pretty good question. Let's move towards part C. P and Q have the same molecular formula as G. All right. Complete the table with the expected observations for the reaction of P and Q with the named reagent. If you're reacting with bromine aqueous, if you're reacting with aqueous bromine, so this is carboxylic acid. The P1 is carboxylic acid, so there is no reaction of bromine with carboxylic acid. So you can say that no change. Yeah, no observation. Right. Then if you talk about the second one, so this is what? This is one of them is ketone and one of them is alcohol. Again, there is no reaction of bromine with them. So you can say that no change. Right. And then they are saying 2,4-dinitrophenyl hydrogen, DNPH. It is used to check what? This is used to check carbonyl compounds. So out of these two, we just have Q, which is carbonyl compound. So it will show what? Orange precipitates. And again, there is no change because this is not the test for carboxylic acid. If you talk about sodium carbonate, we know that sodium carbonate acids can react with carbonates to form salt, carbon dioxide, and water. So definitely carboxylic acid shows some reaction and show the effervescence of what? Effervescence of carbon dioxide, and there is no change because there is no reaction of carbonate with carbonyl compounds. Let's move towards the part D. If you talk about part D1, they are saying that what? The structure of compound L is shown or represent a hydrocarbon chain. A student was asked to deduce the full structure of L. The student analyzed L using infrared spectroscopy. The following spectrum was obtained. Identify the bonds responsible for the absorption, mark X and Y. We know that 1740 पे जो आपके पास आती है, what is that? X is always carbon and oxygen double bond, right? If you talk about Z1, so Z is what? It is nearly 1,000. So definitely it should be carbon and oxygen single bond. All right. Okay. And then they are saying what? Absorption Y shows that L has a carbon-carbon double bond present in an R group. The student decided to treat L with hot concentrated acid by production manganese. The product of the reaction are shown. This one, right? Name M. What is M? What is the name of M? So if you focus about this, 1, 2, 3, 4, 5, 6. 6 carbons with the carboxylic acid. So it should be hexanoic acid. Right. And use information in D to deduce the molecular formula of L. What should be the molecular formula of L? L. This one. L. Okay. So it should be actually over here. R is not shown over here. So we need to find out what is the molecular formula of L over here. क्या होना चाहिए? So कह रहे हैं कार्बन कार्बन डबल बॉन्ड है. हमने किया क्या था? हॉट कॉन्सेंट्रेटेड हमने फोर्स हमने ट्रीट किया था. ठीक है. तो ये टूट कर ये 2 बने हैं. ठीक है. एंड देयर शुड बी सम कार्बन कार्बन डबल बॉन्ड एज वेल होना चाहिए. और वो कार्बन कार्बन डबल बॉन्ड की वजह से आपके पास ये स्ट्रक्चर बन गया है. ओके. अब देखें यहाँ पर अगर आप फोकस करें तो यहाँ पर कार्बन कार्बन डबल बॉन्ड होना चाहिए था. कार्बन कार्बन डबल बॉन्ड यहाँ होना चाहिए था क्योंकि जब ये टूटेगा तो आपके पास कार्बोक्सिलिक एसिड यहाँ बन जाएगा और दूसरा वाला भी कार्बोक्सिलिक एसिड बना है. तो यहाँ पर जो कार्बन था उसके साथ आपके पास क्या मौजूद है बच्चों? यहाँ पर आपके पास 4 CH2 और एक CH3 भी मौजूद है. So we have 6 carbons over here, and if you talk about carbons over here, 1 2 3 4 5 and 6, right? So 6 carbons over here. 6 and 6, 12 carbon हो गए हमारे पास. 12 carbon. And if you talk about H's, so H कितने हो गए हमारे पास यहाँ पर? Definitely 2 over here, 2 over here, 1 over here, and 2. No, so the over here we should have 2, and it should have 1 over here क्योंकि कार्बन कार्बन डबल बॉन्ड होगा. ठीक है, यहाँ पर कितने हैं आपके पास? 3, 4 2s are 8, 8 and 1 9. इसका स्ट्रक्चर बनाना पड़ेगा. This should be like this. This is carbon carbon double bond. Then this should be 1 2 3 4 5 6. 1 2 3 4 5 6 double bond. Okay, 1 2 3 4 5 6, right? So this should be the structure over here, right? And we know that here should be 2 hydrogen, 2 hydrogen, and here is 1 hydrogen, 2 hydrogen, 1 1 2 2 2 2 and 3. So it is 4 5 7 8 9 11 13 15 17 and 20 hydrogens over here. And if you talk about oxygens, so we have 2 oxygens over here. So it is C12H20O2. Okay, so this is actually the molecular formula of the structure over here. And the paper is over. And the time, we just have 1 minute remain to end the class. So inshallah, the calculation one we will do in the next class, inshallah. Okay, because many of the students are there in the class of my O-levels batch.